Hello guys, welcome back to STEM Trainers. Now today we are going to see exponentials and logarithm. So this is very important in year 1 and year 2. So lots of questions will be there in different chapters in functions, maybe integration, differentiation and okay. So let's look at this. So this is part 1. So first we are going to look at exponential functions and in the next video we are going to look at logarithms. Okay, so first, what are exponential functions? So exponential functions are like fx equal to e power x, where a is some constant, you can say, that is greater than 0. So these are my exponential functions. Okay, so there are two types of exponential functions that will be coming in this curriculum. First is, there might be exponential functions where this value a is greater than 1. For example, let's take 2 power x, 3 power x, or you can say e power x. And we know e is approximately 2.7. So you can have functions where a is less than 1. For example, 1 by 2 power x, like this. You can have 1 by 3 power x, like this. Or the same functions can be represented like this also, 2 power minus x, 3 power minus x. So basically this and this are exactly same. No difference at all. So they can write like this also, 2 power minus x. They can write like this also, 1 over 2 power x, or they can write 1 over 2 whole power x. So like this, e power minus x, etc, etc. So there will be mainly these two type of exponential functions. One is where a is greater than 1 and one is where a is less than 1. Okay, so now let's see what their graphs look like and let's try to understand more about these exponential functions. So let's try first the graphs. Now obviously there are two types of functions, as we can see, when a is greater than 1 and when a is less than 1. So when a is greater than 1, the graph is like this as shown in a graph, and when a is less than 1, graph is what is shown in b part. A is less than 1. So as you can see, when my x is approaching minus infinity, my function y or a power x is approaching to 0 value. And that we can see because when x is approaching minus infinity, so actually y is nothing but approaching a power minus infinity. And that is nothing but, I can write this a power minus infinity as 1 over a power infinity. And because a is greater than 1, so 1 power infinity, so that is a number greater than 1 power infinity will be a very large number. So 1 over very large number, it's approximately, we can say this is approaching to 0. And when obviously x is infinity, so a number greater than 1 power infinity will be infinity. So very large number. So graph looks like this. Now what are the important points in this graph? And similarly, we can see this same analysis for y equal to a power x when a is less than 1. So what will happen is, so let me just see. So if when x is approaching infinity, so y will be a power infinity, right? And a is a number which is less than 1. For example, 1 by 2, 1 by 3, like this. So if you take a number which is less than 1, any number, you can take even 0.99, even that is less than 1, and you raise the power of that number to be infinite, that is a very large number, then this value will approach to 0. I hope everyone understands this. We have seen similar kind of things in drawing graphs also. So when you have to draw graph, we were seeing cubic graphs and all. So this is just okay. So that's why the graph is like this. And when x is negative infinity, then what happens is, in this case, when x is negative infinity, then it becomes opposite, right? So then y is a power negative infinity, which is 1 over a power infinity. And we know a power infinity is 0 because a is less than 1. So 1 over 0 is gives you a very large number that is infinite. So that's why my graph is like this in B part. So I hope you understand the graph. Now what are the important points in this graph? There are two mainly important points in this graphs. First is asymptote. What is asymptote? So asymptote, there are lots of definition. It depends which basics you are using to define it. Some say this is like a tangent at infinity. Some say this is a line. For example, this is a line such that the curve is approaching the line but never touching it. So you can say that also. Some say this is like acts like a tangent at infinity also. Something like that. So basically you can see my curve is approaching this line like this, but it is never touching this line. It will continue to go closer and closer, but it will never touch it. So this line is known as asymptote. So you must know this. So what is asymptote for a power x? It's x-axis. Now what is x-axis? The equation of x-axis is y equals 0. This is very important. And same thing for, we can say, for when a is less than 1. Y equal to 0 is the asymptote. That's the first thing that you need to know. What is asymptote and what's the equation of asymptote for a power x? Second thing is very basic, where it cuts the y-axis. Now we know at y-axis x coordinate is 0. So simply substitute x as 0. So when x is 0, a power 0 becomes 1. So we get a point here 0, 1, where it cuts the y-axis. So these two are the important points in this graph that you should know. And both are same for both the graphs. So we have already seen what comes under a greater than 1, 2 power x, 3 power x, e power x, like this. What comes under a power x when a is less than 1? 1 over 2 power x, 1 over 3 power x, 2 power minus x, 3 power minus x, e power minus x. Graphs like this. Okay, I hope you understand these two important points in this graph. Now let's move ahead. Now, first thing that we should know is differentiation or derivatives of exponential functions. So let's take an exponential function fx equal to e power kx, where k is some constant. Now what's the differentiation of this? Differentiation of this will be k times k multiplied by e power kx. So for example, you have, let's say you want to differentiate d by dx of e power 2x. So that will be nothing but 2 times e power 2x. Let's do one more, d by dx of, let's say, some negative number minus 1 over 5x. Let's say you want to differentiate this with respect to x. So whatever that number is, what is the coefficient of x? Minus 1 over 5. So minus 1 over 5 will come outside and rest of the function will remain the same, minus x over 5 or minus 1 over 5x, same thing. So this is my differentiation. Now, one thing that I have observed is, what student make mistake is, they actually consider e power x or a power x to be same as polynomial function. So for example, sometimes I have seen students write this. Differentiation of this is x e power x minus 1. No, it's not this. This is exponential function, not a polynomial function. You can see my polynomial function is when my variable x is on the base and the power we have in terms of some number. Now here it is opposite. The base is some number and the power is x. So these are very different functions. So don't use polynomial function derivative formula for e power x formula. Okay, I hope everyone understands this. So just remember this, differentiation of e power kx is k e power kx. So basically bring k out and rest everything is same. Okay, so that is one thing. Second thing, now next is how they will ask questions based on exponential functions. So what have we learned so far? What is differentiation of exponential functions? What are the graphs? And what are the key points in the graph, asymptote and 0, 1? And what are the exponential functions? So these three things we have learned. So let's see how they will ask questions. First question, they can simply say draw a graph. So for example, we have taken two graphs, y equal to 2 e power minus x plus 1 and y equal to 5 e power x plus 3. Now in the first case, you can see my a value, if you remember, a power x. So a value is less than 1 because it's e power minus x, right? So that is basically 1 over e whole power x. So and 1 over e is 2.7. So 1 over 2.7 is basically a number which is less than 1. Okay. So we have seen that this graph, its shape is, if you remember, its shape will be like this. And this is e power x where a is greater than 1, and we know its shape will be something like this. Now the only difference here is in this graph we have this 1 also and we have this 3 also. So basically we will shift the graph by 1 unit. I hope you have learned the functions transformation. So graphical transformation. So basically shift the graph upwards by 1 unit. Shift the graph upwards by 3 units. Shape will be same. So I will do that only. So my graph will be something like this. Okay. So this will be my graph. And we know this line will be my asymptote, that is y equals 1, because earlier x-axis, that is y equal to 0, was asymptote, but now we have shifted the graph by 1 unit, so this will be my asymptote for the graph. And where it cuts the y-axis, that is very easy to see, because at y-axis x coordinate is 0, so substitute x as 0. So when x is 0, I will get y as 2 times e power 0 is 0, that is 1. So 2 times 1 plus 1, so that is 3. So this point is 0 comma 3. So this is my graph. Okay, now let's quickly draw the graph of B part. So we know the shape will be same, it's only shifted upwards by 3 units. So my graph will be something like this. Okay, so and this shifting is, this is y equals 3. That is my asymptote for this graph. I hope everyone understands this. And what is this point? Again, do the same thing. Substitute x as 0. So when x is 0, this is nothing but 5 plus 3, that is 8. So this is 0 comma 8. So there might be questions like this. They will give you a function like this and they will directly ask what's the asymptote. So just remember this constant, whatever it is, plus minus, that is our asymptote. Whatever this constant is, that gives you directly the asymptote. And where it intersects the y-axis, just substitute x as 0. And remember, shapes are same. Only difference is whether we are multiplying by a positive number, negative number. It only increases the value, but basic shape will be same. Okay, so that's the first type of questions that they can ask you in exams. They can ask like draw this, find asymptote, or find where it intersects the y-axis, etc., etc. Okay, so that is my type 1. Now what is my type 2? Now type 2 is more important. What is type 2? Type 2, they will give you some exponential equations. So for example, I have taken one example. So solve the equation. So they have given 5 power 2x minus 12 into 5 power x plus 35 equals 0. So now we can see, because this is an exponential function, so this equation becomes exponential. So we have to solve this. Basically, we need to find value of x. Okay. So first thing, that most of we have done this similar kind of equations in stealth quadratics also. So if you haven't looked that video, you can go and watch that video also. Okay, so one thing we discussed in stealth quadratic also, that is that students sometimes have doubt in this, is if you take 5 power x as t, now what is 5 power 2x? So 5 power 2x, there are a couple of ways to see this. One way is you can write this 5 power 2x as 5 power x square. because we know powers will multiply. So anyways, this will be x into 2, that is 2x. So this is nothing but t square. Now there might be some students who are doubting this, because I have seen even some of my students say, sir, I don't understand this properly. I don't know why you have written this. So very simple way, another way to look at this is 5 power 2x is nothing but 5 power x times 5 power x. So this is nothing but t times t, that is t square. So I hope you understand now. Okay, so if 5 power x is t, then 5 power 2x is t square. So my equation changes to now t square minus 12t plus 35 equals 0. Now I have a quadratic. I think everyone can easily simplify this. So the factors will be t minus 7 and t minus 5. 7, 5, 35, 5 plus 7, 12. Correct. So t will be equal to now 5 and 7. But remember, we have just solved for t now. We need x. Okay, so let's take the first case when t is 5. T is nothing but my 5 power x is 5. So when is 5 power x equal to 5? That is 5 can be written as 5 power 1. So from this I can directly say my x is 1. As simple as that. Okay, B part. If 5 power x is 7. So now for this, what will happen is you will have to use little bit of logarithms. Otherwise you can't solve this. So basically what happens is you have to take log on both sides. So take log on both sides. So it will be log 5 power x equals log of 7. Now there might be some students who don't know log. So don't worry, in the next video we will discuss log, and then you can come back here and see this if you are having problems. Otherwise I think mostly students learn exponential and logarithms in straight to straight classes. Okay, so this will be x times log of 5 equal to log of 7. So my x value will come out to be, now you can use your calculator or you can just leave it like this, no problem. Log 7 over log 5. This is my second answer. So I have two answers in this case. X is 1 or x is log 7 over log 5. So this is how they can give you the exponential equations. Okay, let's go for type 3 now. What else they can ask? So what else they ask is they can give you some modeling questions. And these are important. Generally, these are 6 mark, 8 mark questions because it has generally 3 parts or 4 parts. Okay, so these are very important. So let's look at this. One problem is there. A heated metal ball is dropped into a liquid and its temperature degree Celsius. T minutes after entering the liquid is given by T is equal to 400 e power minus 0.05 T plus 25. Okay, so temperature of the metal ball after dropping into the liquid is given as a function of time in the exponential function like this. Now find the temperature of the ball as it enters the liquid. Okay, let's solve each part one by one. So A part, find the temperature of ball as it enters the liquid. Obviously when it enters, we will say time t is 0. So when time t is 0, what is my temperature? So T will be equal to 400. Now what is e power minus 0.05 into 0? That is e power 0, that is 1, that we already know. So plus 25. So this will give me 425 degrees Celsius. Okay. So this is the temperature of the ball as it just enters a liquid. B part. Find the rate at which the temperature of the ball is decreasing at the instant when time is 50 minutes. Okay. So we need to find the rate at which temperature of the ball is decreasing. So basically you need to find dt over d small t. That is rate of change of temperature with respect to time. So for that, we will have to differentiate this function. And we have discussed that when you differentiate e power kx, so k comes outside. What is k here? K is nothing but minus 0.05 and rest of the function remains same. So e power minus 0.05t and differentiation of 25 is 0. So just 0 plus 0. So this is my rate of change of temperature. And obviously because it is coming out to be negative and anyways they have given it is decreasing, right? So anyways it's coming out to be negative. So it means actually the temperature of the ball is decreasing. Okay, so what is this value coming out to be? And we have to find specific time, that is 50 minutes, when time t is 50. So let's find this value. This will come out to be minus 1.64 degrees Celsius per minute, because time is given in minutes as you can see in the question in the first line, and temperature is in degrees Celsius. So this is negative. So what is my answer here? The rate at which temperature is decreasing is 1.64 degrees Celsius per minute. That negative take care of decreasing. Okay, let's try the C part now. This was a good one, important. Okay, explain why the temperature of the ball can never fall to 20 degrees Celsius. Okay, how do we do this now? Okay, so this is my temperature, 400 into e power something plus 25. So if I somehow find the minimum value of this temperature, then I can say whether it is below 25, below 20 or not, right? So I think that's the case here. So what we will do is, okay, as you can see, when we increase the time, that is as time passes, the temperature is decreasing. So obviously I can say that when my time is infinity, time is approaching infinity, right? Temperature T should be minimum because it is decreasing. So obviously when time is very large, then temperature is almost minimum, we can say. Okay, so when T is infinity, and we have already discussed this, that this is nothing but, okay, let me just write it here so that you can understand it more. We have already discussed this, but anyways, so e power minus, we have already discussed, minus will be 1 over e power 0.05 into infinity. This is just, I am writing this to explain to you. This is what you don't have to write. This is just for explanation so that you can understand what's going on. Now this will be infinity, and 1 over e power infinity will be a very large number. So 400 divided by very large number will be 0. So basically this value will be nothing but approaching to 0 as time is approaching to infinity. So it means my temperature will be 25 degree Celsius. Or better, let's not write equal to, because it can never be equal to 25. And this value will be something, right? 0.0000, lot of zeros and then a very small number. So this will be close to 25. We can say this is approaching 25. So obviously the minimum value, it can never attain 25 degrees Celsius. So how can it attain 20 degrees Celsius? I think that's a logic here. So they are asking, explain why the temperature of the ball can never fall to 20 degrees Celsius. So your explanation will be, as time is approaching infinity, my capital D, temperature is approaching 25 degrees Celsius. So temperature of the ball is never attained 25 degrees Celsius. So how can it attain 20 degrees Celsius? So that's a logic here. I hope everyone understands this. Okay, so that is all for this exponential functions. So these are the three types of questions that they ask: graphical questions, equations, or modeling questions. So I have tried to give you everything on this topic, but still, if something is left or you want something more, you can always write it in the comments and I will try to answer them as soon as possible. And if you like what you are seeing and if this helps you in any way, then please like and subscribe and share it with your friends. Thanks for watching STEM Trainers.